Hi, welcome back. We promised to give you some guidelines to solving practical problems using Venn diagrams. We promised to do two set problems and then three set problems. In this episode, we are covering two set problems. Take it cautiously because the same step will be applicable to the three set problems. Now, we'll be giving you examples and illustrations. So the main purpose is the steps to solve it. With the steps, with the concepts, you can solve any problems that comes under these. Now, with the two set problems, the concept of Venn diagrams can be used to solve problems using two or three set problems, right? Now, as explained earlier, if U is a universal set of A and B, right, where these two are intersecting or subset of the universal set, then there are four regions in the Venn diagrams. Whenever any two-set problem is given, each of the regions must be represented correctly on the Venn diagram or in the diagram. With this, we can solve any problem. So here, we have the U here and U, all the members in U. And all the members in U is everything in the box, everything outside the circles. That's what it means. Everything outside the circles in that. So here, our U will be region 4. Now, the mathematical expression connecting these regions is N into A union B, or bracket close, equal to N of A plus N of set B minus N of A intersection B. This is the region 2, right? Then you can give it as equation 1 or whatever, where N into A union B is equal to N U minus N of A union B all complement. Don't worry, we express this better. You understand it? Now, if A and B have no complements, what it means that if there's no region in 4, there's no members in 4, right? There's no members in 4, that's the complement, no complement. Then N into A union B all complement is equal to 0. So there's no need bringing it there. And then N of U is equal to N of all the sets. That's in the set under what discussion. So we have A and B as the subsets. So in three set problems, you see them maybe probably A, B, and C. But here it's only 2. So the N means all members of elements A and B, putting them all together will be equal to what? The U. That's what it means. Now let's see. N of U, that's region 1 plus region 2. We have the indications here. Region 1, this is region 1, region 2, region 3, region 4. With this description, it's very easy to understand. That's why they are using the regions. For newbies or maybe when you are now learning, this is how it's expressed with ease. So right now, we have region 1 plus region 2 plus region 3, 1, 2, 3, and then plus region 4, probably equation 2. We are just giving the description. That's why we are expressing them maybe 1 and 2, whatever. Now, if A and B have no complements, then N of U is equal to A is equal to U. Sorry, is equal to N all into A union B, right? And that of N into A union B all complement is 0. Here, all complement here, everything here is 0. That's when there's no complement. Right, so that's what it means. Now, statements such as each student reads at least one subject means that region 4 is 0. Note that N of A means that the number of elements of set A. Right, so this is what it means. Sometimes this statement can actually put you off. Right, it can put you off or can even make the whole thing very opaque, obtuse, difficult to understand. Right, so they just put them there to give you more description, more understanding. Sometimes it can rather become confusing. It's only English, so just put them literally. Like we said, when you're solving problems, put everything into literal terms so that you understand it for yourself before you tackle them. So that is what it means. I hope you are getting the point. So now let's go into illustrative examples. Here we have what example 1, which is in a class of 40 students. In a class of 40 students, 30 read mathematics, 20 reads English. each student reads at least one subject. What it means that there's no complement here. That is what it means. So at least every student did something. None of them were idle, or none of them was idle, right? Now, how many students read both mathematics and English? So now, this is where we start with the solution, the steps. So stay tuned. Now, identify the number of students reading each subject. So, and the number of students reading each subject. That's where we deal with what? The whole of one region. Let's say set N, not only the complement, not only everything under that set. So in terms of diagram, is the whole of what? A, the whole of B, A, or maybe the whole of B before you come to look for this alone, or maybe this alone and this alone. So that's what it means. Now, so identify the number of students reading each subject. Now, let U, that's the universal set, be equal to the students in the class, all the students in the class, including the math and English and any other subject, right? Now, N of U, that's the total students in the class, is 40. Now, let's look for M. M is students who read math. So, everything under the region of A. We are not being specific, maybe A only or B only or any complement. Everything under that particular set. So it's what? 30. Right? Now, everything under English is 20. So you see. Now, X. We are letting X be equal to the number of students who read both subjects. So that will be the intersection. That's what it means. Now, let's go to step 2. So these are the steps that you have to take into consideration. We told you we are not only interested in giving you maybe a question, the solution is A, solution is B, solution is 1, solution is 3. No, that's not our concentration. Because if I should tell you that, let's say a question, the answer is A, the answer is B, answer is 3 or 4. What if you are given another problem, and which is not the same as what you were given? So the concept is very, very important. So that's what you are doing. So you may realize that after giving the concept, I may not bother myself tackling each solution or each question under each of the topics. At least I will solve one, but I'm not going to concern myself with that, because besides that, there's no even time for me to be doing more questions, because on TikTok the time limited is 10 minutes, right? Until I hit 1K, where I can be holding live sessions and then tackling some of these practical questions to be solving, right? So here, our focus is the understanding, the concepts. Now, step 2, identify the number of students. Now, there are 2 subjects. So draw a Venn diagram of 2 intersecting sets and label them as shown in figure 1.19 using the information given under the problem. So note, the number of students who read both subjects is represented with a variable, say X. So this is the mathematical expression in terms of Venn diagram. That will be N into math intersection E. That's the English, and that is X. So in the diagram, this is what we have. So always try to represent them this way. It makes the math, the solution, very easy to see everything vivid. So N of math, that's everything here. Everything here. So X is included. That's what? N of M. Then the same thing is applicable to English. That is it. And then we see that everything. So step 3, there are 30 students in math as what? The subset. So there are 30, that's X, 30 minus X will give us this portion. So with everything under math, we are looking for only this. So 30 minus X, that is it. The same thing applicable to the rest of the problem. So once again, look here, right? Putting everything together, this is the solution that you realize that X is actually equal to 10. That's the intersection. So the same expression that we did for math, do the same expression for English, and then we put them together in this expression, right? So X, 30 minus X, blah blah blah. Take a screenshot or pause the video and do this. You realize this is the answer. So thank you very much for watching. We'll see you in the next one. Bye for now.